Alright.
Alrighty. So we want to just go over the first questions real quick, and then
Move on to 3
3 and 4, and then do 5.
Yeah.
Okay. I actually looked at 5 yet. And so, question 1.
Does everybody understand?
Yeah.
One?
How do you guys?
Yeah. Well, first I
Uh,
got confused because I thought it was like double that, but then I realized it just said total chromosomes.
Yeah.
yeah.
I didn't look it up on Wikipedia.
So,
It was funny because they had the wrong picture there for white-tailed deer. It was an elk for white-tailed deer. It was really loud because they had the wrong picture. So
Yeah, so tetraploid would be 4 times
34.
34.
yeah,
So
So
136.
136. And then B was 68.
C69,
Yep.
D 67.
and D68.
Yep.
Cool. And then two I thought we were supposed to just put one answer down for the
Me
first.
too.
So I only put
I
down.
only put
trisomy, monosomy, the first 3.
I put trisomy, non-disjunction, monosomy, and then I went back in and I put in like the other
Yeah, I
things.
put all of them. D was only deletion though, right?
Yeah,
Yeah.
and then E was only reciprocal translocation.
Also, they called it like Robertsonian translocation in like the notes and everything.
Yeah,
How did you know that that was like the same thing?
I did.
I was just like,
I
It says
guess.
translocation. I'm like, it's gotta be one of those. It can only be a translocation.
I think that's what I did too.
Yeah, that was.
Yeah? Okay.
How do you? Oh. Yeah.
But I like looked
One-
all over and it never said that they were the same thing.
1 and 2 were pretty self-explanatory. But the other 2 were the ones that I still don't even know how to do.
3 and 4.
Yeah.
So I got 3.
So I learned how to do 3 just like purely off of this slide. But what I did wrong is like if you look on this one, it's like showing where the inversion happened on the chromosome. And if we look in the one that she gave us, it's like on this side
Yeah.
of the chromosome. And so you just follow this pathway.
Wait, what?
So
So maybe Caleb, do you have the answers pulled up?
I have the answer
Or
right
like
here.
yeah, that's what I mean.
Oh,
the question. So if you look on there, it's like in alphabetical order, you know? So look for the spot where it's not in alphabetical order.
Right, which was H.
Yeah. And what side of the centromere is that?
Left.
Left. So on here, it's on the left side of the centromere. But on this one, it's like right around the centromere.
Right.
And so that's why you would follow this pathway. So pretty much what you do is like either they're not gonna like cross over and they're just gonna be fine and they're just gonna be what they were.
Yeah, so I got that part right. I got those 2 products right
Mm-hmm.
because I was able to like see that it is
Yeah.
outside the centromere. But the middle ones, I just didn't know how to put all of that together.
So for those, so if you look on here, so you got the A.
H, G,
Yeah. So it's, for example, for the Premium's product one would be this right here. Then how you would put it together was so if you look on here, you can see it says see how it shows the crossover site right here? That's right in between, that's like between the C and the D, see?
Right.
And then you go down here, and this line right here is between the C and the D, and this is between the C and the D.
The centromere?
And the centromere, the crossover site right there.
So between C and D.
C and D, and that's C. That's where it's gonna
Okay.
go wrong at.
Right.
And so,
For us, it was E.
yeah, for us it was E and F. So then,
Because it told you right here.
yeah, exactly. The crossover is between E and F. And so, like on here, E and F. So then, I haven't. So yeah, it's going to be between this one right here and this one right here.
Okay.
And so what happens with that is
Does it just take? Does the one just take the section without the centromere, and then the other one takes the section with the centromere?
Yeah.
Is that just pretty much how it happens?
Yeah, so
here?
that's why one ends up with two centromeres,
Two centromeres.
the other one
and
ends up
one.
with one.
Okay.
So yeah, so then you
I just draw a line down like in between the E and the F. Yeah.
Okay.
Yeah. And then I'd put together the two that wouldn't have the centromeres, and then the two that would have the centromeres.
So you would, the two that wouldn't have the centromere?
yeah, so like these two here, these are gonna flip up basically and go together, and these here it's gonna flip up and go together with this one. See? So like that's one chromosome and that's the other.
Right.
And so that's how it's gonna match up for if it's
Not over the centromere.
yeah, if it's
I can't remember the name of it.
it's
Paracentric.
paracentric. Yeah, it's paracentric.
Okay, so what was product two?
So product two, I mean, which one was that?
Oh wait, no, we're talking about the one without a centromere.
Without a century, for me, that was product one. But that was A, B, C, D, E, all capitalized, and then F, G, H, V, A, all lowercase. And that's because, like she showed, you basically just draw a line down how it matches up right
So
here.
you put these together. Or,
No, these,
okay.
yeah, all on the same side go together.
Okay. And then for the one with two centromeres,
It's the exact same thing, it's on the other side. And so, so the two centromeres was capital O and NLK through F, capitalized, and then it was lowercase E, D, C, I, J, K, L, and N. That makes sense?
O and M L K, and then what? And capital J.
Yeah, so I mean, it's just going backwards from where it was. So it's O, N, L, K, J, I, H. So going I, H, G, F. So you know, it's just going all these here. You're going this way,
Right.
and you come back and go down.
And then there's a second centromere.
Yeah. Because the centromere, wherever the centromere is here,
It stays.
that's the stays, yeah.
Okay. So that makes sense, but how did you guys know to put that together?
So I just looked at this here, and I saw how they did it here. And so I saw that, you know, it hooks up with the first capital A, B, C, D, I mean, A, B, C, sorry, and then little D, E, A.
Where is that?
So little D, E, and then you can't see the A, but it's right there. D, E, A. So this one here hooks with that one, and then the other one has to look with it.
Okay.
That's how I looked at it. And so like on here, you're looking at it, then it was between the E and the F. So just like we did here, you draw the line between the E and the F. And then that is how it's going to hook up. They're going to hook up with the opposite.
That makes sense. Okay. So this is a paracentric.
Paracentric, yeah. And then, did you guys get B, C, and D on that one?
I don't know if these are right.
So it should be.
I think I got them right.
So it should be the two normal ones,
Product one or two. Okay. Yeah, the two normal ones.
and then the two eccentric and dicentric. The
The
two not
normal ones.
C, and then D. You should have one eccentric and two dicentric.
Okay, I got it.
Yeah, so it's basically.
Acentric is no centromere. Dicentric is.
Yeah. So this is going to be your
Acentric.
dicentric.
Oh, so it is products 2 and 3.
Yeah.
Oh, you just have them numbered differently.
Yeah.
Oh, okay. Yeah, I got that one right.
Yep. Cool.
Yeah, I knew what was supposed to happen, like centromere wise, and like based on that picture, but I just didn't know what letters went where.
Yeah. No, that one took me. I think was the longest one. This one. Yeah. Okay. So are we good at number 3 then?
Yeah.
Number 4. You said you got that one right?
Yeah.
Okay. Let me read your answers.
So for A, cell number 1, I got A, B, centromere, C, D, E, F, G, H, I, all capitalized.
Yep.
Oh, well, they're all. And then R, S, centromere, T, U, V, W, X, Y, Z.
Mm-hmm.
And then cell 2, I got A, B, C, D, E, F, X, Y, Z, and R, S, T, U, V, W, G, H, I.
Yep. Which I got.
B, I got A, B, C, D, E, F, G, H, I, and R, S, T, U, V, G, H, I.
I think. Did you put the W?
T, yeah. I might have just not said
Okay.
it, but it's in there.
Yeah. Okay. Cool.
And then 2, I got A, B, C, D, E, F, X, Y, Z, and R, S, T, U, V, W, X, Y, Z.
Uh-huh.
And then C, I got A, B, C, D, E, F, G, H, I, and A, B, C, D, E, F, X, Y, Z. And for 2, I got R, S, T, U, V, W, X, Y, Z, and R, S, T, U, V, W, X,
So
Y, Z.
I got those switched up. I don't know which was the. So
Does it matter?
I don't know if it does. Does it?
I don't know.
Where's the question? So suppose that the translocation crosses the chromosome. Function. What's this one? Reveals that are present in each sex.
She has it listed on the answers as A's first. And
Yeah, she does.
but
So that's
I don't think it matters.
Yeah, I think
It's just the two
the
different
different ones. Okay. Cool.
So you didn't get this one?
No.
Okay. So again, I went off the side, but pretty much like you just have to know. So alternate segregation means that it was like the 2 normals and the 2 not normals, right?
Is that A?
Yeah. So A, if you look at it, the answers like they're all A, B, C, D, E, F, G, H, I, and R, S, T, U, V, W, X, Y, Z.
Right.
So these are both normal, but then these are both translocated.
So on the picture they have
So those top 2 are normal,
normal.
and then the bottom are translocated. And then on B,
Wait, hold on. But then how did you know what section was translocated?
just which one wasn't in alphabetical order. So a normal is A, B, C, D, E, F, G, H, I,
Right.
Yeah, so
but it wouldn't be normal for it to be A, B, C, D, E, F, X, Y, Z.
yeah, so for the this is for the alternate one, right?
Yeah.
A. So the alternate is just the chromosomes diagonal from each other. From each other, so you into the same cell, right? So here you notice that one and that one, and this one and that one, right? Make sense?
Wait, what?
So for alternate, the chromosomes diagonal from each other segregate into the same cell. So this one is diagonal to this one,
Right.
and this one is diagonal to this one.
Right.
And so that's so here. Back to the question. So how they line up is, from what I understand, the blue, no one really seeing the same, and the purple to purple. So it's always going to be in that same kind of position. So the normal ones are going to be diagonal from each other, and the abnormal ones are going to be diagonal from each other. Which is for alternate. That's all. I'm not understanding this. Is that right? Does that make sense?
Yeah, but then so how did you how does this translate into what you were given?
So this one here is the normal. these two here, right? This
the
one
top and the bottom.
and this one are the normal ones, right? So,
Right.
and these two, the two middle ones are the abnormal ones, are the ones that were switched out.
Right.
And so that's the pattern that's going to always follow. Is the normal ones are going to be diagonal to each other, and then the abnormal ones are going to be diagonal to each other as well.
Okay.
That makes sense. Because of how they line up. And that's how you figure out for the other ones here too. Because you know,
That's a good way to say it, right?
the chromosomes are going to line up with the letters that are the same. And so they're going to try and do that. That's why it makes that shift. Does that make sense?
So all that this was saying was that the two normal ones were in cell 1 and the two abnormal ones were in cell 2?
Yeah.
Oh,
And then for
okay, that makes sense.
yeah, and then for B, then what is it asking for B?
Adjacent 1 pattern.
Yeah, adjacent one. So it's the same thing, but adjacent one, like on here, is the one that's all purple and then mostly blue, and the one that's all blue and then mostly purple. So
Okay.
it's the top and the bottom. So they divide like this. Oh, sorry. Like this. So it's the same thing. It's still diagonal. It's these two are together. And these two.
Okay.
Because here, like I said, chromosomes on the top and bottom halves of the cell segregate to the same cell. So over here, it's going to be ones that are there. One that is all normal, and then it's mostly like that normal one, and then the same for the
So
other
these
one.
two.
These two.
are 1, and then these two are in the other.
Exactly. And that's adjacent one. And that's always going to be the top and bottom of the translocation.
So there was no like gene processing going on. It was just more like what goes into what cell. Oh.
Yeah, just sorting out.
Okay, I think that's what confused me. Okay, and so then adjacent 2 says chromosomes on the right and left halves of the cell. So it's this way.
Yeah.
So then that would be the AB normal and the RS normal? Or the RN?
Or that type. See. There you go. So it's the one. Sorry. So it's right and left half. So I said it wrong last time, I think. So this one is the one where it's all normal and mostly like that.
So, okay, so we're adjacent 2, it's the normal one, and then the one that's mostly like it?
Yeah.
So it would be this and that.
Yeah, exactly.
I think it's like most easiest to go off of like the first letters too, because like that's where it's like the same. And so pretty much just like in the last one, it's just like the ones that are like the same. They start off ABC and ABC.
Yeah, so
And then
so in
RST
C,
and
the two
RST.
that are the most similar are together in both. And
Yeah.
then in, I think,
Yeah,
that's
and then
it.
yeah.
Adjacent
Makes
1,
sense behind you.
yeah,
Ones that
adjacent
are the
1,
most
the
different.
top half is the ones that are most different. Oh, okay, that makes sense.
Yeah.
Okay, I get it. Thank you.
No problem. Cool. So are we good with number 4 then?
Yeah.
Right. Number 5 then. So have either of you looked at it?
I looked at it. I knew it was drawing meiosis.
Oh.
So
Really?
Non-disjunction.
Draw this whole entire thing.
there's like a couple different
That's
things.
pretty good drawing. Let me see how much time. We're at 20 minutes. Yeah, 10 minutes.
Okay. So do you want to just like split it up then? Like into 3 parts?
Sure.
And then we can come back and compare?
Yeah.
Okay. So how many are those? 1, 2, 3, 4, 5, 6. So 12, so you can step 4. Does that work?
4 sections of it.
Yeah. Or 4 parts of it, and we can come back and compare one with another.
Okay. I
wanna
can do the first 4.
Okay. I'll take the middle 4 then.
And I'll do the last one.
Okay. It's 12, right? I count that right?
Yeah.
Yeah, so I'll do Anaphase 2, Telophase 2 of Analysis 1, and then Metaphase 1 and Anaphase 1 of Analysis 1. Okay, cool.
Is this just supposed to be one cell? Or one chromosome?
Let's see, this question is...
Diagram the behavior of 2 pairs of homologous chromosomes.
Okay.
So 2 pairs of homologous chromosomes, that's 2.
Yeah, so... Like that, yeah.
Yeah. Okay.
So, did you do it then? All of it?
Yeah.
Okay, then wait. I already do that. I didn't know that I could do all of that. Okay, so we can,
Maybe we can just
let's
go
go over
through it.
hers.
together.
Okay.
Yeah, it's so much better. Yeah, 'cause
Okay.
it'll take a while to draw out.
Okay, so it said that it wanted you to use color to distinguish between like the maternal and the paternal. I just mainly went off of like a couple slides and like my previous drawings of meiosis and stuff. So pretty much like
Did she put it?
she didn't put any answers on there.
Not yet.
No, not yet.
Okay.
So she'll probably do that later. So metaphase 1 is when the homologous pairs line up, right? So here they are, and I mean, obviously you can probably like put them in a different order, but I just put them by maternal and paternal, and so I labeled them like purple and blue. So they're lined up here with their matching ones, and you have the metaphase plate going down the middle, which she wanted as well. And then anaphase is where they're actually going to separate.
Getting pulled out.
So in non-disjunction in meiosis 1, this is going to start to take place in anaphase 1 after they start getting pulled apart. And so on one side, there's only going to be one homologous pair being pulled apart, and then on the other side, there's going to be 3. So instead of
2 and
these
2.
ones just, grabbing 2, this one on this side comes over and it grabs this other one.
Right.
And so then when telophase 1 and cytokinesis happen, you're going to have 3 homologous pairs in one and then just one in the other.
Okay.
Now in metaphase 2, the sister chromatids line up down the middle and are split by the metaphase plate, and then they're going to be pulled apart. And so
Sorry,
this one...
someone's calling me here.
You're fine.
I'm gonna take it real quick, okay?
Okay.
Hello? Yeah, it is.
So the first one's in non-disjunction meiosis 1, the other one's non-disjunction meiosis 2. And the one in meiosis 2 produces 2 normal ones and then 2 messed up ones. And then this one's, they're all messed up.
So,
Okay.
yeah, so I thought, so it's actually my dad's
I
vehicle.
think I just had trouble with the first, where like the problem-solving ones, because I didn't like have anything to go off of, and I didn't really understand those pictures.
If,
I
what
like.
do exactly, so he still
I
has
didn't know. I didn't look at pictures enough
I can give
to
him a
know
call.
that like how you knew which one to do was on like what side the messed up would
And
be.
then I'll
So,
let you know.
I didn't get number 2.
Sometimes I wish that there were like
Sorry about that.
instead of like all those videos, like there were some example videos, like like they walk you through the
Sorry
problem
about that.
Yeah.
or similar problems. I don't know.
Yep.
The information on the videos is good, but like I
It's
feel
just
like a lot of it
straight up
doesn't
like
really apply.
information.
Yeah. To the
That's true. Like
problem
sometimes like
60% fries with shrimp.
the
Burger.
I got the same thing.
Oh, yeah.
Oh my gosh.
50% off.
50% off fries with such bad shrimp.
I might actually go do that.
Date night.
Alright,
Okay.
so we were in anaphase 2.
So, in anaphase 2, well, pretty much, meiosis 2 is going to happen normally. There's just going to be 3
Right.
in one and then 1 in the other. So,
So in the 4 daughter cells.
they're all going to get split up. And then 3 are going to get pulled when telophase 2 and cytokinesis happen. 3 are going to get pulled into this one, 3 are going to get pulled into this one, and then just 1 and 1. And so,
So So all the daughter cells are messed up.
Yeah. So these two have an extra one, and these two are missing
That's
one.
trisomy and that's monosomy, right?
Yep.
This is a monosomy. Is that how you say it?
Yeah,
Monosomy.
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 Monosomy. I don't know.
Trisomy. Monosomy, that's what I say.
Monosomy.
Okay. And then in meiosis 2, meiosis 1 is going to be normal. So metaphase 1, they're going to line up again. But this time they're going to be half, split right in half. There's going to be 2 that are going to go into one and 2 that go into the other. And so they're going to be matched up. But then in metaphase 2, what happens is a whole homologous pair.
Homologous.
It's
Homologous pair.
It's not just
Yeah, it's going to be pulled over. And so this one is going to split in half, but then this one is just not going to be split in half. And so then when we come down here and these two are split in half, this one's going to be normal.
right.
And so then you're going to end up with 2 normal cells, but this one is going to end up with 3 and then with 1.
Okay. Let's compare the two. So
Yeah.
the difference then. So this occurs in the interphase 1, or interphase meiosis 1.
So if it occurs,
Or it
if
occurs-
non-disjunction occurs in meiosis 1, then you end up with 4 abnormal cells.
Yeah.
But if it occurs in meiosis 2, then you end up with 2 normal ones and then 2 abnormal ones.
Makes sense.
I just think of it as like, I mean, like, I guess you could kind of see, like, in metaphase 2 that it, like, grabs, like, but this is anaphase, where it's, like, grabbing it. But, like, I guess you could kind of see that it's just grabbing one of them as, like, kind of how I drew it. But mostly you're going to really see the difference in, like, the anaphases. Because that's when they start to pull, and you can see that, like, whoa, that one's just grabbing like a whole homologous pair for whatever reason.
That seems dramatic.
Whoa.
Okay.
So is the problem that's like what's happening? Is it in metaphase 1 and 2 then? Are we just not connecting? Is that what's causing it?
Yeah, it's like the spindles are like, this one's not doing its job, and so then when this one attaches, it just takes the whole thing.
Okay.
Since the spindle's not connecting to the other side of the chromosome.
Yeah, I mean, I'm not positive, but I feel like there would be like multiple reasons, like that there was like a disconnect. Like, what if like one of the spindles wasn't like long enough, or like it had like I don't know.
Yeah.
Like it was bent, or what if like the centromere, like there was a deletion and the centromere was like off a little bit, and so they couldn't like sort of connect. Like that's just kind of how I think about it in my mind.
That makes sense.
It was messed up in some way, and it just didn't grab it.
Makes sense.
Alright.
How much?
Do we have any other questions? I think we're
so.
good.
Have you taken biostats yet?
Mm-hmm.
I have.
It's
How was
super
it?
easy.
Really?
Yeah.
Yeah, I mean, they let you take a whole paper into the exam. At least
Yeah,
when I
that's
took it,
right.
like a whole
How
like,
much?
sheet of information.
I compared to I don't know, like Chem 105.
It's really easy.
Oh.
Like,
Okay.
our science classes are a billion times harder than that class.
Really?
What I did is I just, I mean, I don't know if that's good, but like it says you're supposed to read the whole chapter every time, but it was really confusing and I never understood what it was
Did
saying,
you
so
just
I
read
just
the
watched the
summary?
videos.
Oh, you just watched the videos.
Yeah, because there's
That
like a
makes
YouTube link to a professor here who explains each section,
Okay.
and he literally tells you how to solve everything. Using the concepts from the book, but you don't have to read a whole chapter of statistics.
I am very math minded. It's very weird, and I keep telling myself that I probably should have gone into math because it's so easy for me.
It's not
I
bad.
just had to skim the chapters and go over, like, you use SPSS, and I just had to, like, skim through and read, like, the steps to do it, and then I read the summaries, and then I would take the quiz, and I just, like, got 100%, like, every time.
So is it like an easy A class?
I got 100% on 3 of the exams. I can't do that with any other class.
Wow.
Like,
I didn't get 100, but I got an A.
it was like super easy.
And like as long as you do the work, then you're gonna get an A
I
basically.
think you can take a note card on like 2 of them. And
I could take a whole paper.
page on like
I took it with Brother Hathaway. Okay,
I
that's.
took it with Sister Mary.